दोस्तों, मैं अभिनव नेगी और धीरज सर एक बार फिर से 5 घंटे के गैप के बाद, एक लंबे 9 घंटे के मैराथन के बाद, जिसमें हमने हर एक चैप्टर, हर एक टॉपिक आपको डिटेल में कराया है, और उसके मेल्स, बहुत सारे बच्चों के टेलीग्राम में मैसेजेस हम बहुत सारे बच्चों के मिल रहे हैं, और ये सब जो सुबह मैराथन लिया उसके बाद जो आपके फीडबैक्स मिल रहे हैं मेल के थ्रू, व्हाट्सएप के थ्रू, या आपके पास टेलीग्राम के थ्रू, दोस्तों पिछले 24 घंटे से लगातार उठने के बाद बिल्कुल भी थकान अभी भी महसूस नहीं हो रही है। इट इज ऑल ड्यू टू योर फीडबैक्स। पूरा मेहनत किया, रात भर उठे, पीपीटी बनाई, उसके बाद जब सुबह डिलीवर किया और बच्चों ने इतना उसको सराहा, तो अपने आप में एनर्जी दुगनी तिगनी चौगनी हो गई है। और उसी डबल एनर्जी के साथ हम इस सेशन में आपको प्रैक्टिस कराने वाले हैं क्वेश्चंस की। सोम कंप्लीट हुआ था सुबह, पीडीएफ हमने अपने टेलीग्राम सिविल बाय अभिनव सर, मैकेनिकल बाय धीरज सर में दे दी है। ऊपर हमने अपने टेलीग्राम के मैसेजेस लिंक भी डाल दिए हैं, और अब यहां पर हम आपको क्वेश्चन कराने वाले हैं। और साथ ही साथ उन 2 स्टूडेंट्स का नाम जिन स्टूडेंट्स ने मैक्सिमम क्वेश्चंस के सही जवाब जल्दी दिए थे, बहुत सारे बच्चों ने सही जवाब दिए। प्रशांत थे, यादव साहब थे, नेगी साहब थे, प्रशांत एलएसी थे, स्वप्निल थे, बहुत सारे बच्चे थे। और मैंने सुबह भी कहा था ये बहुत मुश्किल है कि हम उनमें से किसी को पिक कर पाए, क्योंकि वो मैनुअल कैलकुलेशन होगा और उसको कैलकुलेट करना बहुत ही मुश्किल है। तो हमने एक का वादा किया था, हम 2 बच्चों को कैश प्राइज देंगे। उनका नाम भी आपको धीरज सर भी फटाफट से बता देंगे, लेकिन उससे पहले आप सबसे आग्रह है कि सेशन को शेयर कर दो। धीरज सर डबल एनर्जी से आगे हैं क्वेश्चन लेने। ओवर टू धीरज सर।
Thank you, sir. First of all, guys, I would like to say thanks for your wonderful response. Like in the morning when we came just up to 5 AM, we have made the PPT, then we were live, and you guys have shown what a level of energy. और उसको देखने के बाद हमें लगा ही नहीं कि हम रात में सोए नहीं है ऐसा कुछ. And we have also given our more than 200%, I will say. And guys, once again, we are here to complete that session, because without practice session will be like incomplete, I will say incomplete. So with this practice session, my dear, now that session would become a complete one, because practice is also required for GATE examination. So please tell me, am I properly audible and visible to all of you or not? So Kalyan, as you were asking, I am telling you here we are going to cover the questions from the entire strength of material. Some questions Abhinav sir would be taking, some I would be taking. Okay, it would be covered. It would be covering all the concepts of strength of material, which are generally coming in the examination, or which we feel that from those kind of topics the questions would be coming. So guys, I'm really actually me and Abhinav sir were talking about that students are sitting from morning till evening. We were still changing. Like कभी अभिनव सर ले रहे थे, कभी मैं ले रहा था, तो हमें फिर भी एक गैप मिल रहा था. But you guys from the morning you are having the class, and what a patience you have shown, and definitely it would be paying back to you in the examination. So Abhinav sir, shall we start now?
बिल्कुल सर. Guys, this is the session. PDF is given in the Telegram group. The Telegram group link is given above. Okay, this is Dheeraj sir. Okay, from morning we are here. So what is the need of introduction for himself, the great Dheeraj sir? Okay, so this is me. Okay, then this is the Telegram group. The sir is showing civil by Abhinav sir and mechanical by Dheeraj sir. Okay, civil by Abhinav sir and mechanical by Dheeraj sir in both the telegrams. After just 5 minutes of the session, I have put the PDF in my group, and sir has put in his group. Okay, guys, there is a scholarship, 90% scholarship if you want to attain and come in the courses. It's totally your choice. Yeah, if you don't want to come, it's your choice. If you want to come, it's your choice. It will be on 8 Jan. Even if you don't want to come, you can give this scholarship test so that you can check your performance on the all India level. Guys, now for this schedule is mechanical. Today we have taken, now tomorrow Sonu sir will be coming 10 AM. Okay, Sonu sir will be coming 10 AM, and in steel Sahu sir will be coming 10 AM tomorrow. Complete steel today, complete, yes, today, because 12 AM is already done. 12 AM is already done, so it will be today, and Sonu sir 10 AM today in the morning. Now, after this, these are all topics that we have covered, and from these topics only we will be taking the numericals. Okay, from these topics only we will be taking numericals. But before that, the announcement of 2 students. Let me tell you, there are various students here. Deepak, Swapnil, Prashant LSAT, Yadav, Negi Saab. I can't even Pratiksha. Various students are there. Okay, I have taken the screenshot. Okay, so by the combined reason of me and Dheeraj sir, there are so many students. Akash, Priyam, Teju has given so many answers. Smart, Shashank, okay, Banod, Dinesh. Okay, these are the students who got maximum answers correct. Revati, T Lover, Bhaumik, okay, Tiksha, Umar, various students here, more than 40, 50, even I cannot name all are champions. Okay, and to be very honest, I already told in the morning that we are not computers, we cannot even exactly calculate your time, but still, instead of one, me and Dheeraj sir has taken 2 students. You have to mail your details, okay, UPI and ID and everything on my mail ID और धीरज सर मेल आईडी धीरज सर आप भी अपने को एक बार मेल आईडी टाइप कर दीजिए
ओके सर
हाँ उस पे भी लिख दीजिए सर उस पे भी लिख दीजिए ठीक है तो यहाँ पर आप हमको एक बार अपना यूपीआई आईडी कर देना और 2 स्टूडेंट्स कौन से हैं सर अगर आप अब मानस नाम था ना इनका तो
यस सर
मानस एक है और दूसरे का नाम तो कैलकुलेट मानस everyone is winner guys. I'm so sorry for the others. Even my calculations may be a mistake as I told in the morning because there are so many students and more than 45 students. I have taken the data of all students who have watched complete 9 hours marathon, and other name is Abu, what was that name? Something Abu something name was like me only. That name was क्या नाम था सर उसका? Eunice Anbu Meno. Eunice Anbu Meno. Are they in the chat box right now? Please let me know. Manas is here. Manas, please mail me and Dheeraj sir. Okay, cash prize will be there. Eunice Menu is right now, he is not here, but if he is there, he'll be. Please let me know your mail ID. Okay, yes, Minhaj is also there. Ashish Sharma, Minhaj, all these students. Mayur बीच में शायद गायब हो गए थे वो सब मयूर ने सर कहा भी था उस समय कि वो देखते देखते उनको नींद आ गई थी आकाश all the students are excellent guys. I'm sorry for others but all are champions in my eyes. Over to Dheeraj sir.
But guys, don't worry. We are also going to continue these kind of things in other subjects. We will try for that. Okay. So this is just for the motivation, nothing more than that. And I know when I was also taking the session, all of you were giving the answer, and it's just you can say a matter of luck. You can say because we cannot exactly judge as we have not given you the paper. We don't know the exact time in which you have answered. So we've just instantly taken those snapshots and the names we have found most the number of time for those questions. According to that, the prizes are going to be given to you. So it doesn't matter actually कि price कितना है जैसे कुछ student लिख रहे हैं OD है तो वैसा कुछ नहीं है. This is just for
OD भाई हमारे पास नहीं है यार. अभी I don't have OD. Might be Dheeraj sir. Are you having OD?
No sir. I also don't.
Okay. Mayur was also there, guys. It's okay.
Yes,
you all are saying that
many students like I feel Mayur was also there throughout. He have also given the answers correctly. So there are many. We are going to see the names in that.
Sir, actually, the students are saying thank you over mail and WhatsApp messages to me. But let me tell you guys, with your overwhelming response now and with your overwhelming love and your feedback, guys, if I was knowing that you will be giving this kind of support and love now, I'll be every day coming with 9 hours marathon from the last 7 months. Okay, sir, if you permit, then shall we start the session?
Yes, sir. So
sir, what will be happening now, guys? Sumant is saying, please make the price at least 1 lakh. Sumant,
sir,
yes,
we will do that after the GATE examination. When the GATE exam result would come.
Even more than 1 lakh.
Even more than 1 lakh.
See,
so big prize, the exam also should be bigger.
Samant, we are not giving prize 1 lakh. But let me tell you, we'll make a person in you, and we will make your competition exam like that. You will be earning in crores, not in lakh. So we'll make you up to that level.
So you are going to earn
OD. Okay, sir. Then you can begin. What will be happening now? Na? Sir will be taking 2 questions. Then I will be coming with 2 questions. Then sir will be coming with 2 questions. Then I will be coming in 2 questions. This will be rapid fire session. Okay. So, sir, I'm just hiding myself so that your screen is big.
Okay, sir. Okay.
Okay, students, I'll be just there after 2 questions.
So guys, here is the first question in front of you from the Mohr circle. The topic I have taken for the larger time today. So that is from the Mohr circle. You can see this Mohr circle is given to you. And the question states the Mohr circle for certain stress system is shown in the figure. The principal stress, that is major and minor, in MPa, and you can see plus for tension, minus for compression. These are the four options. This is the Mohr circle. You can see this distance is given as 250 and this distance is given as 150. So you need to find out the principal stresses sigma 1 and sigma 2. Let us see how many of you give the right answer. I am looking in the comment section. I feel some of you have started giving answering as well. Yes, yes, yes. So Ashish Sharma is saying D. Hello Amir. Great, great. Thanks Ramesh Mohan. So Junaid is saying B would be the answer. Ashish Sharma is saying D is the answer. Okay, very good. What about others? Yes. Mekala Shekhar is saying B is the answer. Mayur is saying B is the answer. Kalyan is saying B is the answer. Deepak B. Minhas B. Sumit. Okay, hi Sumit. Vishal B. Adnan B. Akash B. बहुत ही बढ़िया. Yes, yes, yes. Sumit, hi. Manas, very good. SK, very good. Ramesh Mohan, very good. So guys, majority of you have given the answer to be B. Some of you have also given A and D also. So I would like to say the B answer is correct. So how you will be solving it? You know that when we are talking about this thing, you can see if this thing we know 250, then obviously the half of this is going to be 125. So you can see this is the center of Mohr circle. Center of Mohr circle is having the coordinate sigma star comma 0. So we are knowing the value of sigma star, that is 125 MPa. Okay. So my dear, if this we are already knowing, we need to find out the radius of Mohr circle. So this radius we need to find out. You can also take this. The point is same. So to get this radius, you can use this triangle and you can apply the Pythagoras. So when you would be going for the Pythagoras, you would be writing r ka square is equals to square root of, it is going to be 150. The height is going to be same because tau xy and tau ix are same. So we would be saying 125 ka square plus 150 ka square. And I feel after doing this, you would be getting the value 320 point. Just let me check what is the value. Sorry, 195.256. So this would be coming out to be 195.256 MPa. This is the value we are getting for the radius. Okay. Square root of radius ka square. Square will get cancel out. You will get this to be the radius of Mohr circle. 195.256 MPa. So my dear, once we are getting the radius of Mohr circle, you know that if we know radius, what we need to do? If my dear, you are going to add, if you are going to add the radius into this 125, you would be getting the principal stress 1. Because Mohr circle, where it cuts the x-axis, you will get the principal stresses there. So maximum principal stress you would be getting here. And similarly, if you will subtract the radius from this sigma star, you would be reaching to the sigma 2. Because the extreme point of the Mohr circle, where it is cutting the x-axis, will give us the principal stresses or principal plane. So if you want me to write the sigma 1 would be sigma star plus radius. That also we have seen today, sigma star minus radius. So this is also a kind of check what you have learned from today's marathon session. So when you would be finding this, you would be getting 320.26 and second answer is minus 70.26. The student who are having just a small idea that principal stress would be coming at the extreme point of Mohr circle, they even will not answer it as A and C, because you can see one principal stress is positive, other principal stress is negative. So answer could be either B or D. So after calculation, we get to know the answer is coming out to be B. So majority of you have given the right answer. So guys, let me check one more thing for this question. If I will ask you one more thing for this case, whether the plane of pure shear will exist or not, what would be your answer, guys? क्या plane of pure shear exist करेंगे यहाँ पर या नहीं? मैं देखना चाहता हूँ how many of you are going to give the right answer for this question now. Whether plane of pure shear will exist or not? बहुत बढ़िया, बहुत बढ़िया, बहुत ही शानदार. प्रियांशु, दीपक, शुभम, अजय, विशाल, मयूर, बहुत ही बढ़िया guys, बहुत शानदार. So as I already told you that if principal stresses are of opposite nature, then we are going to have plane of pure shear existence also. So every one of you have given the right answer. That's really nice. This is the second question from deflection, and after me then Abhinav sir would be taking the next two questions. This question is having a cantilever beam where you need to find out the deflection at point A. This is point A, this is point B, and this is point C. So you need to find out the deflection at point A. So the vertical deflection at the free end of a cantilever beam subjected to a load of 100 Newton as shown in the figure. So let us see how many of you give the right answer for this. Yes, 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 yes. So please make session on conventional question session, please. Sumit, actually this is going on the practice session for GATE. In GATE, the questions are coming off objective level. But yes, when ESE conventional paper would be there, for that we would be having the sessions of conventional question also. So don't worry. Okay. Very good. Sir, रोज morning में theory और night में question होगा क्या? क्योंकि उसी हिसाब से time set करें. Please reply. Vishal, we are also trying for the same based on the way you have shown the interest. We are very much planning for the same, that we will be having the practice session. Okay, so rest in the tomorrow session you will get to know. But for mechanical, I will tomorrow at midnight the session is there for thermal. For civil, Abhinav sir would be clarifying when he will be coming. Okay, so just answer it, guys. Arun is saying B, Manas B. Very good. Black hole B, Minhas B. Okay, Ramesh Mohr B, SK B. Ajay B, Ashish B, Shubham B, Akhil B. Yes. Great, Altron. That's really great. Thanks for your love and support. So we are starting, guys, how to solve this question. So my dear, you know that from A to B, there is no load. So if I would be asking you from A to B, as there is no load, no bending moment is there. So deflection diagram for AD is going to be a straight line. So if you would say how the deflection curve would be made, it is going to be like this. So as there is no load between A to B, we can say the slope of A is equals to slope of B. Yes, it is going to be. So if you want to write the deflection of A, you can see the deflection of A is having one component which is deflection of B. And to find out this part, we can write theta at B into AB. So you can say deflection at free end will be deflection at B plus theta at B into AB. So as you know, when thetas are very, very small, we can definitely write them in this way. Okay. So when you are going to put this value y at B, so for that you can write this is going to be minus P. Then the length for that would be BC. PL cube upon 3EI. This is going to be the first thing. Then you would be having plus theta B, that is minus. Why minus? The slope is going to be clockwise. Clockwise we are going to consider as negative. Minus of P L square upon 2EI. Okay. And guys, that is going to be into AB. So when you would be putting the value of AB, BC, then my dear, at the value of load, you would be getting the answer to be 1400 divided by 3EI. So B is going to be the right answer. Okay. So I feel everyone have given the right answer, and I'm really feeling happy that the way you guys are answering. So very good, Abhishek, Mayur, Vishal. So Abhinav sir, I feel it's your turn now.
Okay,
so guys, some students are asking whether this midnight practice session would be for other subjects also or not. So for mechanical, I feel tomorrow is there by Sonu sir. For civil, I feel you can update the students.
Okay, sir, mechanical, it might be most of the days it will be session in the night. For civil, yes, session will be there, but might be not of the same subject. Might be subject is X and midnight questions may be of different subject. Okay, this may happen, but still, instead of giving you false information, let me just ask my team and Let us, all five of us decide, and then I will tell you within next 24 hours. Now coming back here to this question, guys, as I told you in the session also, that deflection will be solved or deflection will be understood through the problem. So this is one question. Here, there AB is a cantilever beam, and below this, these are simply supported. This is cantilever, that is AB, and this is simply supported. Okay, on cantilever, this is simply supported. Now, if I make the free body diagram, of AB, okay, EI is constant, then here is a P force on this. Okay. And this beam from the bottom, this is cantilever. And cantilever, there is some force. This is cantilever. This hand is cantilever. This hand, and in cantilever, there is some force. Okay, this is some force. Bottle is P force. Okay, this is cantilever. So simply support will pushing it upward. This will pushing simply support downward. Simply support will pushing it upward. Okay, this is cantilever and this is simply supported. This hand is simply supported. Okay, so this is putting it downward. It is putting simply support downward. Simply support putting upward. Like I am putting 80 kg downward to the floor, and floor is putting 80 kg upward. So here there is reaction R, and to the beam CD, simply supported, C and D, this R will be downward. Okay, now moving further from here, guys, actually this point is in contact. So if this is going, this hand is going 3 mm downward, this point is also going 3 mm downward. Okay, the deflection of both these points where they are joined is same. Okay, deflection of both these points are same. This and this is same. Now, deflection of B point here. In this case, what is the deflection of B point? P minus R, length is L, cube by 3 EI. Standard deflection formula for cantilever, PL cube by 3 EI at the free end. Okay. Now, the deflection formula for this one is PL cube by 48 EI. So, reaction here is R downward. Okay, the downward displacement of this is this much, and for this, it is R L cube, but length is 2L. So, L cube, it will be 2L cube upon 48 EI. Okay, so it will be 8 RL cube by 6 EI. So 3 EI and 6 EI will be cancelled. It will be 2 here. L cube will be cancelled. So it is 2P minus 2R is equal to R. So from here, R is equal to 2P by 3. That is A option. Let me check. Yes. Swapnil, विशाल, धीरज सर, मेरा मन कर रहा सबको प्राइज दे दूं मैं यार, ऑफिस बुला के मजा। टीचर को इससे मत कर। सेम हियर बेटा, ऐसे मैं मुड़ा और सब बच्चों का ए है, सब यहीं के चैंपियन हैं, सब यहीं से चैंपियन आ रहे हैं। ओके, इसके बाद नेक्स्ट क्वेश्चन अगेन डिफ्लेक्शन, एज आई प्रॉमिस दैट डिफ्लेक्शन विल बी हैविंग मोर क्वेश्चंस। नाउ द डिफ्लेक्शन इज आस्क्ड ऑफ व्हिच पॉइंट? बी पॉइंट। डिफ्लेक्शन इज आस्क्ड फॉर द बी पॉइंट। Now, if I take this load here, so here will be P load, and this is P into L by 4 movement here. P into L by 4. So this is transferred here like this. One P force downward and then PL by 4. Otherwise, there are numerous ways to understand. Let me just let me take the free body diagram of this. BCD. Okay, G. This is P force. Okay. And this is L by 4. When Dheeraj sir is solving the question, I found this misprint here. So that time I don't know how to rub this. So I make black color and then I did this. Okay. So this is L by 4. So making it balanced, if I take this beam out, if I take this portion out, making this balanced, P force downward. So P force will be upward here, internal forces. Morning I told you internal forces. P into L by 4 here. So here it will be P into L by 4 like this. Okay. Now, if I make the free body diagram of another part, this AB. Now, internal force I told in the morning, is equal in magnitude and opposite in direction. So P upward, so here P downward. And here PL by 4 is clockwise. So here PL by 4 is anti-clockwise. Okay, as we know to do these kind of things. No need to make two for free body diagrams like this. Okay, we can directly shift it here, P downward. Movement is like this. Now, what is asked? Deflection of B point. Now, deflection of B point due to this P is PL cube, length is L, Q by 3L. Please check, guys, when you're applying this formula, check if it is L, 2L, 3L. Not like always you write PL cube by 3L. If the length is 3L, then it will be 3L ka whole cube. Okay. Now, due to this movement, it is going upward. Due to this downward load is going downward, but due to this movement is going upward, ml square by 2I. So minus PL by 4 into L square by 2EI. Okay. Now, what you do here, take PL cube by 3EI common. Okay. Now, taking this common, here it will be 1 minus PL cube. Take PL cube by EI common. Take PL cube by EI common. Okay. So, here it will be 1 by 3. And here it will be PL cube by EI common. Okay, 1 by 8. So 1 by 3 minus 1 by 8. LCM will be 24. So 5 by 28 minus 3, 5. 5 by, yes, B option. बेइज्जती होने से बच गई. Yes, all are B. मेरे से पहले मेरे student are doing. Sir, after the GATE exam, I will give you the best prize for overacting. Okay, Dheeraj sir, now you can come, sir. For मयूर कह रहा है ओवर एक्टिंग के पैसे काटो इसके.
नहीं सर, वो आपको ये कहना चाह रहा है कि he would be giving you some very good results.
पता नहीं सर, what happens actually in YouTube ना, when students are writing comment, I don't get this sarcasm or this genuine तारीफ. Okay, just kidding. Now Dheeraj sir is coming with question number 5. Then Dheeraj sir will be taking 2 questions. Then I will be taking 2 questions. So Dheeraj sir is taking the question of strain. Sir, मैं आंसर बताऊं क्या इसका?
नहीं सर, प्लीज आप वीडियो ऑफ करिए.
अरे सर, आप मेरे को भगा रहे हो. Okay, sir.
Yes, guys, what would be the answer for this question? This is question number 5. Okay, and this is from strain gauge row sets. The row set shown has been used to determine the following strains at a point on the surface. What should be the reading on gauge number 3? So let us see how many of you give the right answer for this. Yes, I'm looking in the comment section. Yes. Okay, मेरी आवाज साफ नहीं आ रही है. Okay, after this question I will try to correct it. Okay, just try to solve this question. Okay, अभी कुछ देखता हूँ मैं voice के लिए. Tell me the answer, guys. What would be the answer for this question? Govind is saying C would be the answer. Okay. Shubham is also saying the C as the answer. Now please tell me voice is clear or not.
सही है.
हाँ, Swapnil very good. Mayur, Neeraj, Ajay बहुत ही बढ़िया. Yes, waiting for others. Only 5 to 6 students have answered. Very good, Vishal Sharma. बहुत ही बढ़िया. Yes. Great. Junaid, very good. Prince, very good. Mikala, very good. Yes. Wonderful, guys. Wonderful. So, guys, when I was taking the Mohr circle and principal stresses part today, then you have seen one thing, that sigma 1 plus sigma 2 was equals to just a second, was equals to sigma xx plus sigma yy, and then we have seen sigma theta plus 90. The summation of normal stresses on two perpendicular plane, that summation is always remaining the constant. So here also, if you will see that this 1 and 3 are perpendicular, 2 and 4 are perpendicular. And you know, every relation what we have derived for stress is valid for strain also. For normal, you can directly replace sigma by epsilon. And for shear, you can replace it by gamma by 2. So you can write epsilon 1 plus epsilon 3 is equals to epsilon 2 plus epsilon 4, because 1 and 3 are perpendicular, 2 and 4 are perpendicular. So you can see epsilon 1 is given as 428 microns. Epsilon 3 you need to calculate. Epsilon 2 is given as minus 65 micron, and epsilon 4 is 183 microns. So you would be getting epsilon 3 to be minus 310 micron. It was an easy question if you know this wonderful concept. So that is why I was saying that it is going to be very, very important thing, and you need to be ready for that. Wonderful. So votes are also there. Great, great, great. Prabhakaran, actually we are going to solve around 20 to 25 questions, and rest would be given to you as homework. Okay. So that much number of questions we are going to do. This is question number 5. So moving to question number 6. So guys, I feel this question is once again from deflection, question number 6. So as deflection sir have promised, so we are fulfilling the promise. One more question is there. A cantilever of length 2 meters carries a uniformly distributed load. Okay, carries a uniformly distributed load, that is carries UDL like this. Okay, and this is 2500 Newton per meter for a length of 1.25 meters. And it is also having a point load of 1000 Newton at the free end. Okay, this is also there, 1000 Newton. And this is nothing but 2500 Newton per meter. So this is given to you. And they are saying if the section is rectangle, so rectangular section is also mentioned, where 240 is the depth and 120 is the width. So you can find I is BD cube by 12. And if you want to find Z, that is BD square by 6. Okay. So they are asking find the deflection at the free end. So you can see here we need to apply what, which method, which principle. You can see that and just do it. This is slightly more calculative, but this type of questions are coming from deflection sometimes. So for that purpose, we have taken this. So just solve it. I'm waiting for your answer in the comment section. Yes, yes, yes. Yes, Prabhakaran, I feel you get your answer. Sai, Akhil, SK, Shekhar, Prince, Junaid, Ajay, Vishal, Neeraj, Mayur, Manas, Swapnil, Shubham. Yes. So guys, every day we are going to have marathon session at 10 a.m. and we will be completing one subject on the daily basis. And for mechanical, as we already have discussed, you would be having, and for civil also, you would be getting the update soon. Okay. So be ready for such practice session. That will definitely give you the proper picture. Ajay is saying the answer to be B. Okay. What about others? Ajay is saying the answer to be B. What about others? Yes. So my dear, I would like to give you a hint there. You need to apply principle of superposition. First of all, you need to find out deflection due to this force P, which is 1000 Newton. Okay. Then you need to find out the deflection due to this UDL. Due to this UDL. For a length of 1.25 meter, UDL is present. And the total length is mentioned as 2 meters. So obviously for rest of the length, there is nothing, 0.75 meters. Okay. So you need to find out deflection at A because of this point load. Then deflection at A because of UDL. Then you need to take the summation of that. That is said to be principle of superposition. So here you would be using minus PL cube upon 3EI. Yes, that would be the formula. And here, you know, once again, this is similar to the previous question I have taken. So if this point A, this is point B, you need to write this as deflection at B due to UDL plus theta at B into AB. And due to UDL, you know, it is going to be minus WL4 upon 8EI. and it is going to be minus WL cube upon 6CI, and into the length is nothing but AB. But I would like to say for this length is 2 meters, but for this length is 1.25 meters. So this question will give you a feel of convention, the student who was asking for conventional. Okay, so just solve it. Then wonderful. I feel some of you have already answered it. Great, 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 Ajay. I feel you found your mistake. So guys, you guys are doing really fantastic. So the time which I have used to write the formulas, you have just calculated, and I would like to say everyone, the answer is correct. 2.922 is the right answer. Okay, so everyone have given the right answer, so that's really fine. So this was question number 6. So I feel Abhinav sir, आपका turn आ गया.
बिल्कुल sir, बिल्कुल sir. Okay, so guys, this is a previous year question, but I'll a little bit modify it. Okay, this is a shaded portion. Okay, here this is a shaded portion, and it is asked that what is the force here, but I will just little bit modify it. Okay, first of all, if I draw the bending stresses, this is a causing compression at the top, so that means it is something like this. Okay, compression at the top, that means if I make the bending stresses, neutral axis will be the centroidal axis. This is 150, so neutral axis will be here. This is neutral axis, centroid. Okay, above compression and below tension. Now we want to find the force here. So what is force? Force is stress into area. What is area? What is area? Area is this 25 into 50, 25 into 50. What is stress? Now the stress here is at this level, the stress is somewhere here sigma, and at this level, stress is 0. So here it is 0, here little bit more, little bit more, little bit more, little bit more, and then sigma. So it will be 0 plus sigma by 2. Since it is linear variation, then only we can do this. This is linear variation, then only we can do this. Otherwise, we have to find the volume of stress prism. Okay, 0 plus sigma by 2 into this. So what is sigma? I told you in the morning, m by I into y. What is m? M is this. Okay, what is I? BD cube by 12. I is BD cube. So B is 100 into D is 150 cube by 12. Okay, and y is the distance from neutral axis. Y is 25. Okay, so sigma is m, that is 16. I BD cube by 12, you can convert it in proper units, into y. Y is 25. From here, sigma you will be getting as 14.22. Sigma you will be getting as 14.22 Newton per mm square. And this value you will be getting as 8.9 kilonewton. This is a PYQ. I want to change it little bit I am changing. Yes, Aisha Sharma. I want to find out the stress at this portion, dotted, not shaded portion now. I want to find out the stress here in the dotted portion. Can you do this? Yes or no? Just tell me. I'm not asking the answer. Can you do this? Can you do this? Again, the force is stress into area. Can you do this? Just let me know in the comment section. Stress into area. So area is, this is 50 and this is 50. 50, 50, 50, 50. Area is 50 into 50. And stress, guys, here the stress is, here at this level, stress is 14.22. 14.22. 14.22 here is this level. At this level it is sigma max. So sigma plus sigma max by 2. Sigma is this plus sigma max by 2, like this. Okay, sigma plus sigma max by 2. Are you getting this? In this 50 into 50 area, na? In this 50 into 50 area, na? Here the stress is 14.22, that is sigma. And here the stress is sigma max. You can find this by similar triangle also. By 2 into area. Or you can find by this formula. M by I. M is same, I is same, but Y here is 75. So it will be 3 times from similar, because here I am multiplying with 25. M is same, I is same, here I am multiplying with 25. For here I will be multiplying with 75 or by similar triangle. So you can find the value. Got the concept, guys? Everybody, have you got this? Mechanical engineering by Dheeraj sir. ओके सर, किसी ने आप ही का नाम का आईडी भी बनाया है। एक्सीलेंट एक्सीलेंट।
मेरा ही है सर वो।
अच्छा अरे सर आपने डिलीट कर दिया मैसेज कुछ?
हाँ सर, वो मैं गलती से इस आईडी से कर दिया था।
ओके नाउ मूविंग हियर to the next question, as we promised that we'll be doing more deflection question. This is A, this is B, this is A, this is B. Okay, and here this is C. This is C. Okay. Like this. This is B. And this is C. Now this will be pushing reaction here upward if I break it, and this will be reaction R downward. But B point is same. But B point is same. But B point is same. So in this part, what is reflection of B due to UDL? W L4. L is 4A. 4 by 8EI minus RL cube by 3I. R will be pushing it upward. RL cube. 4A का whole cube by 3EI. Okay, is equal to, in this part, what is reflection of B? What is the deflection of B? Downward I am taking a positive, upward I am taking a negative. So this R is downward. Here the only mistake the students do in sign convention. R is PLQ by 3I. I am again saying downward. See, this W is putting it downward, I am positive. R is this R. This above R is putting upward, I have taken minus. So this, in this green portion, this R is putting downward. So plus, and this W is also downward. So it is W into L4, 2A4 by 8I. From here, you can find out the value of R, find R, and then that R value put here or here, you will get delta B. I'm not wasting time in calculations. I'm not wasting time in calculations because I know the real commandos here who are not watching Netflix at midnight, not watching Hotstar at midnight, not watching any other entertainment channel in night. They are watching the pure content. So they are already very capable of doing this calculation. They are more interested in getting the concepts. Okay. So this was question number 8. 4 by me, 4 by Dheeraj sir. You can find the value. Now, Dheeraj sir.
Yes, sir. So guys, अब थोड़ा सा चेंज करते हैं, बहुत हुआ डिफ्लेक्शन. Now let us see the question on the taper bar. Okay, so this is the question from taper bar, and he's asking that a tapered rod shown in the figure is subjected to an axial pull of P. The ratio of its extension based on actual calculation to that of based on average diameter. Okay, so you need to find out the ratio of delta taper to the delta prismatic. So there are two consideration actually. One consideration is in front of you, that is will be giving you delta taper, and the second, by mistake, if we are going to have a prismatic bar of the average diameter. What do you mean by average? Average means if this diameter is D1, this is D2, so average would be D1 plus D2 by 2. So you need to find out the elongation. Today only you have seen this concept also in the morning session. So yes, let us see how many of you give the right answer for this one. So great, wonderful guys. So I feel majority of you have already answered it. A. बहुत ही बढ़िया. Ajay is saying D. Okay. So some are saying A, some are okay. A is for the previous one. For this, the answer is D. Very good. Wonderful. Manas, SK, Vishal, Swapnil, Mayur, Ramesh Mohan. Very good. So guys, I feel every one of you have given the answer to be correct. D is the right answer. So you know what is the formula for delta taper? It is going to be 4PL upon pi E D1 D2. Okay. And then you know what is the formula for delta prismatic? It is 4PL upon pi E D square. So guys, you need to take the ratio of them. Load is same, length is same, and only the difference is in diameters, where D1 and D2 are given to you. D1 is given to you as what? The value is given 0.05. D2 is 0.15. And what would be average diameter? Average diameter would be 0.05 plus 0.15 divided by 2. So the ratio would be coming out to be 4/3. D would be the right answer. Really wonderful, guys. बहुत ही बढ़िया. Majority of you have given the right answer. Very good, Neeraj. Very good, Manas, SK, everyone. So guys, now this question I have taken 2 to 3 times before also. But my dear, from stress strain diagram, it is the best question I found. Okay. So that is why in this session also we are doing it, because this type of question are been there in the previous year's GATE questions also. So guys, this is a wonderful question. Let us see how many of you are able to answer it. The stress strain relation for a material is approximately given by this. Then he is saying to elongate for a bar made up of this material of diameter 50 mm and length 2 meter under axial tension of 300 kilonewton. So my dear, you need to solve, you need to find out the elongation. Okay. Let us see how many of you give the right answer for this. Those who know the concept, they can try. Those who do not know, I am telling here. Okay. First of all, find out the value of stress, which is force by area. They have mentioned the load, they have mentioned the diameter. You can find out this value of stress. This value of stress would be coming somewhere here. Okay. So that would be coming somewhere here. Corresponding to that, you would be having this strain also. Okay. Then my dear, you can use the similar triangle concept where you are having two triangles. One triangle is this yellow one and other triangle you are having this green one. Okay, this green one. So using this, you know this value, you know this value, you can find out this one. So once you get this one, you can find out the total value of strain. So once you would be getting the total value of strain, then delta L upon L is the strain. Okay, so you can use it and you can find out the deformation also. Okay, how you can find out, because this is known to us now. So you just need to find out this, then you can add this one. So just to solve it, guys, and you would be getting the answer for that. Let us see how many of you give the right answer. So I have given the concept. Very good. Deepak have said the answer to be 8.37 mm. What about others? So guys, you guys are really doing nice. Vishal Sharma is also saying the answer to be B. What about others? Manas, SK, Swapnil, Shubham is also saying the same. Swapnil same, Neeraj same, Shubham also same. Very good, guys. Very good. So Mayur, are you trying it or not? SK, very good. बहुत ही बढ़िया यार. Ajay, very good, guys. Very good. So first of all, when you would be finding out this value, sigma, so you would be getting a value around 152 or 153. So after getting this value, you can use the similar triangle concept and you can find out this strain. Once you get this strain, you can add this 0.002 into that. You can find out total strain. After that, you can find out the length and you would be getting the answer to be 8.37 mm. So that answer is really correct. Very good, Junaid. So I feel, sir, I have done these two questions. Now, once again, it's your turn.
Sure. So guys, I'm here with the boat now. And in this boat, there is a Saklonda. Saklonda means she's alone. No other companion. Okay. So now here in this boat, a person is standing with 80 Newton. So guys, how this will be in equilibrium? There is no support, no fixed support. So from where the upward reaction will be coming? Sir, आपने ये क्वेश्चन कराया था क्या सुबह?
नहीं sir.
Okay, so guys, from where the upward reaction will be coming? There is no support, no simple support, no fixed support. So guys, the upward force will be coming from this beyond weight. Okay, the water force, the water thrust, that will be acting as a UDL. And if this total is 80 Newton, okay, so this UDL will be, this is 2 meter. So this UDL intensity will be 40 Newton per meter. If in 40 Newton per meter, then only in 2 meter, it will be 80 upward. Then balancing. Now, if I make the SFD for this, guys, then SFD, you can see the, my and Dheeraj sir, both method is same. Both method is same in different way. in different way. It is something like you are saying Delhi or Delhi, both are same. Okay, so you can see the my method or sir method, both are same. So UDL is upward. Those who have studied AN method, SFD, BMD from me, positive and constant, positive and constant like this. Then downward load, shear force will fall. Then upward load, then upward UDL. So positive constant like this. Okay. Now this is SFD and BMD will be. This is SFD. Now BMD will be. So here the shear force is positive and increasing. So graph is like this. Negative and decreasing graph is like this. You can just see either Dheeraj sir SFD BMD detail class or my class, then you will getting this. Okay. Now always I told you one more thing in the morning. For every symmetrical beam, this is symmetrical beam, symmetrical loading, symmetrical beam. SFD is anti-symmetrical, here plus here minus, and BMD symmetrical. I told you na in the morning also. For every symmetrical question, SFD is anti-symmetrical, BMD is symmetrical. Okay, like this. SFD is anti-symmetrical, here plus here minus, BMD is symmetrical. Okay, so this is a MSQ question. Yes, SFD is a linear. So BMD will be quadratic curve. Yes, SFD will be actually anti-symmetrical and this is symmetrical. So only A and B. Only A and B. Excellent. Not ABD. Yeah, ABD not. Okay, so BMD is not anti-symmetrical, it is actually symmetrical. Now, what happened to my marker? 2, 2, 2. Now, compliance. Just give me quick answers. Again, one MSQ. Again, one MSQ, guys. Everybody. Yes. Tell me. This is, I guess, question number 12. Okay, 6th question sir has taken, and this is my 6th question. This is question number 12. Okay, compliance was guys, stiffness. See, delta is PL by A. So stiffness is P by delta. Stiffness is P by delta. It is A by L. Compliance is flexibility, opposite of that, reciprocal. It will be L by A. So it depends on length, not load. It depends on length A and E. That is B, C, and D. This is the question number 12. Okay, sir, over to you. Okay, Dheeraj sir.
Yes, sir.
Okay.
So guys, I am here with the next question. I feel this is going to be question number 13.
Sir, एक बार बच्चों
now
से
from SFD BMD. Yes, sir.
सर एक बार बच्चों से वो एक बार अपने एक बार सिविल मैकेनिकल एक बार लिख लीजिए कौन सी ब्रांच के. हमको जस्ट एक डाटा मेंटेन करना है, जस्ट फॉर आवर इंफॉर्मेशन, कि हाउ मेनी ऑफ यू आर फ्रॉम सिविल एंड
please write your branch guys in the comment section. We want to know who are from mechanical, who are from civil. Yes.
And guys, I guys, Prince, Vishal, everybody who is right now is in the morning marathon also. Okay, those in the morning marathon also na. Swapnil civil, mechanical civil, mechanical. Shamat is civil, mechanical Kerala. City तो मैंने पूछा नहीं अभी, खैर. Okay, easy way civil. Teju, my dear student Teju, he has also given many answers correct in the morning. Neeraj, yes, mechanical. Saksham bhi hai. Saksham sir, my offline student from Chandigarh. Abhi he's right now JEE in Haryana or Punjab. Mechanical, great, civil. Great. Okay, sir, you can carry on, sir.
So guys, this is from SFD BMD. So as I already promised you, we are covering questions from all the areas. So in this question, a simply supported beam is loaded as shown in the figure. You need to find out the bending moment at point E. So this is the midpoint. You need to find out the bending moment at E. For that, first of all, you need to find out the support reaction. After that, it is going to be very, very easy to find out the bending moment. So just solve it, guys. Options are there in front of you. You know, sagging for, hogging for, sagging for positive, hogging for negative. You don't know that. We have taken positive moment, negative moment. Yes. Wonderful, guys. बहुत ही बढ़िया. Okay, Mayur. So I was thinking, Mayur, you are from civil, but you are from mechanical. That's really great. So you can continue this series with us, marathon series.
Sir,
Okay,
civil
Mayur
का
is saying 4 TM. Yes. So guys, we have also shared our email IDs. If you want to have any other issues in your preparation journey, you can also connect with us. We are always there to help you. Okay. Even on Telegram, you can share if you are finding any difficulty in your preparation journey. So guys, some of you are saying the answer to be D, not some. Everyone is saying D. Okay. So guys, first of all, we will be finding out the support reaction. So you know principle of superposition, you have seen that this 2 TM is making the net moment to be 0. So there would be no reaction because of them. Now we are talking about because of this 2T, 4T and 2T. If you would be finding out the support reaction RA, we are going to use the shortcut. RA is upward, 2T is downward. So you would be writing plus sign 2T, the distance from opposite end is 3 divided by 4. Then you would be having the second 4T. Once again, it is upward, it is downward. So you would be saying 4T into the distance is 2 divided by 4. Plus the effect of 2T, you would be having 2T into 1 divided by 4. And you know there is a kind of symmetry also, because of that both reactions are going to be equal. So you can see here 4 is there. 2 into 3, 6 plus 8, 14 plus 2, 16. So you are going to get RA. You can also write by symmetry RA is equals to RB. This is 4 plus 4, 80. So directly also could be written. But I have shown you both the things. Every time symmetry may not be there. So if symmetry is there, you can directly also write the total load would be divided into 2 parts. But if symmetry is not there, you will go by this method. So you would be getting 40, 40, and you need to find out the bending moment at point E now. Okay. So if you want to find out the bending moment at E, you can see bending moment either from the left or to the right hand side of the section. You can consider, you know, the sign convention. This is for the sagging, this is for the hogging. So you can see this is hogging. So I would be having this to be minus 2T, minus 2TM. This is coming. Yes, if you see the left, this RA would be creating clockwise. So you would be having this 4T into 2. So plus, this is going to be 4T into 2. So 8TM. And you would be having one more, this 2T would be creating hogging once again. So 2T into M. So it is going to be minus 2T into M. So total value would be coming out to be 4TM. Positive means sagging. So answer is D. Really very good, guys. So every one of you have given the right answer, I feel. So yes, Ramesh Mohan, the same I said. By symmetry also we can do. This is from principal stresses once again from the Mohr circle. So on the element shown below in the figure, the stress in MPa, the radius of Mohr circle is R and principal stresses are sigma 1 and sigma 2. This will be a very, very easy question. So you are having 4 options, but in GATE every year they are asking from radius of Mohr circle. So taking that into my mind, I have had this question. Otherwise, I know it is easy. But in GATE, it is also coming. So we need to prepare for the exam. So tell me what would be the right answer for this. Yes. बहुत बढ़िया आशीष शर्मा, बहुत ही शानदार. Wonderful, guys. Wonderful. Yes. Teju is saying A. Easy way is saying A. Ramesh Mohan A. Mayur A. Manas A. Ajay A. बहुत बढ़िया. Shubham A. बहुत ही बढ़िया. Wonderful, guys. Okay. So guys, now I would be telling you how to solve it. Abhishek, Vishal, very good. You can see you are given the sigma x as 110. I don't know why it is hanging. And sigma y as 30 and tau xy also as 30. So guys, the best thing to find out is radius of Mohr circle, because it is nothing but the tau max. And tau max formula everybody would be remembering from today's session also. Sigma xx minus sigma yy by 2 ka whole square plus tau xy ka whole square. Okay. So guys, if you would be having this is 110 and 30. So 110 minus 30, you would be putting the value 110 minus 30 by 2 ka whole square plus tau xy is going to be 30 ka whole square. The answer would be coming out to be 50. So if you want to answer only with radius, you can say answer is A, because there is no other option which is having 50. So if any other option would also be having the value 50, then you need to find out sigma 1 and sigma 2 also. So my dear, you already know how to write sigma 1 and sigma 2. Sigma 1 is sigma star plus radius, and sigma 2 is sigma star minus radius. And what is sigma star? Sigma star can be written as sigma xx plus sigma yy divided by 2. So 110 plus 30, 140 by 2 is 70. So you can write this 70 plus 50 is 120 and 20. So the answer is coming A finally. So I have shown you the calculation for everything. So I feel this was question number 14. Okay, now Abhinav sir would be coming for question number 15. Then I would be coming for other questions. Yes, Abhinav sir.
जी
सर
Okay,
ऐसा लग रहा है कि बस मुझे लग रहा है थकान मिट ही गई है, लग ही नहीं रहा कि हम लोग नहीं सोए, और लग रहा है बस चलते जाए क्वेश्चन।
बिल्कुल बिल्कुल। मैं तो सोच रहा हूँ सर, मैं सोच रहा हूँ हम एक और मैराथन ले लेंगे सोम का, एक अलग टाइप का
सर
स्पेशल
मेरा भी
मैराथन
मन हो
लास्ट
रहा है। पर इस बार सर प्रैक्टिस का लेते हैं, मुझे लग रहा है प्रैक्टिस अब ज्यादा चाहिए होगी स्टूडेंट्स को।
में। प्रैक्टिस का लेंगे, लेकिन वैसे ही चैप्टर वाइज, जैसे उस समय लिया था ना, चैप्टर वाइज करके, और हर चैप्टर का 3 लेवल के क्वेश्चन, बेसिक, एडवांस और एक्सपर्ट लेवल।
Yes, yes, yes. So guys, please tell me how you find this idea of Abhinav sir. If you like it, we can plan like that. So Abhinav sir, over to you for next two questions.
सर हाउ मेनी क्वेश्चंस, आपका कौन सा क्वेश्चन खत्म हुआ अभी? क्वेश्चन
सर
नंबर
ये आपका 15 है, ये 15 है आपका।
ओके, सो विल बी गोइंग गाइस विद 20 क्वेश्चंस। ओके,
Yes, yes.
so this is question number 15. Question number 15 is saying that a bar AC is a rigid bar. Guys, AC is a rigid bar and supported by 3 rods of same material. All these rods, if I take of these shorter rods of length L1, or this one of length L1, or this bigger rod, all are of same material and of same diameter. The bar is initially horizontal, a P force is applied, and it remains horizontal. Okay, guys, rigid bar need not to be horizontal. In this question, this is said as horizontal. Rigid bar can be like this also. The only condition with rigid bar that it will not be elongating or it will not be deformed like this. But yes, it can be like this. Rigid bar can be like this. Rigid bar, this is the rigid bar, it can go like this. Yes, this is the case. This can happen in the rigid bar. And most of the questions in rigid bar, similar triangle will be used in such questions. When earlier the bar is like this, and now it is like this due to some forces, similar triangle is used. 90% questions, similar triangle is used. But yes, this is possible in rigid bar. But if this is rigid bar cannot be like this. That is not possible for the rigid bar. That is not possible for the rigid bar. Okay. Now, in this question, it is saying that it remains horizontal. It remains horizontal. So it is deflected somewhere here. Now, what are the forces in shorter and the longer bar? Let in the shorter, the value, since it is symmetrical. So here, suppose it is coming P1. It is coming P1 here, symmetrical. Otherwise, if you take movement about here, then also both will be same. And this is P2. So one equation is upward force 2P1, P1 and P1. And this P2 is equal to P. And if you check it, all will be satisfying. 0.4 plus 0.4 plus 0.2 is 1. 0.3 plus 0.2 plus 0.4 is 1. 0.2 plus 0.2 plus 0.6 is 1. All are satisfying. So we have to go further. Now deflection is same. So deflection of this is P1, L1, A1, E1. And deflection of this is P2, length is 2L1, A1, E1. It is written that diameter material is same. So area and Young's modulus is same. So from here, L1 cancelled. P1 is equal to 2P2. P1 is equal to 2P2. So putting 2P2 here, 2, this 2, P1 is 2P2 plus P2 is equal to this. So 5P2 is equal to P. So P2 is equal to P by 5. P by 5. So P by 5 कितना होता है? 0.2P. P2 is 0.2P. So this is 0.2P. So this is 0.4 and 0.4 to make it P. Got it? Got it. Now students are faster than me. What can be more? What can be more proud moment for a teacher? Okay. This is question number 15. Now moving to question number 6, the term pure bending, this is, I'm not counting this. Pure bending, M is constant, shear force is 0. Okay, and I am not counting this. This will be question number 16 na? Which question I should take? All other questions are homework that you're gonna ask us. Okay, what is this question? Let me check, guys. I have not read. The cross section of a beam is shown below. IXX is this. It is subjected to load as shown in the figure. The maximum tensile stress. Okay. First of all, this is the question. First of all, draw the shear force diagram. This is 0.3. It is symmetrical. So both will be 0.3, 0.3. Okay. Symmetrical SFD is anti-symmetrical. This is SFD. SFD is anti-symmetrical. SFD is anti-symmetrical. Now if I draw BMD, negative and constant graph number 4 as per AN method, then positive constant like this. So this is the maximum bending moment, 0.3 into 3 meter, 0.4 into distance, 0.9 kilonewton meter. Now what they're asking, the maximum tensile stress. So sigma max as per the flexure formula is m pi into y max. So for maximum, I will be putting maximum bending moment 0.9. What is I? What is I? 3 into 10 to the power 6. What is y max? They are asking the tensile stress. They are asking the tensile stress. So it is a hogging bending moment. Negative represents hogging bending moment. Hogging is like this. So tension is at top. Here it is tension, here it is compression. Okay. So what is the maximum? We are talking, we will be finding y of here, not of here. Even here y is more. Even here this is only more. But if here it is 90 mm, then only we'll be taking this, because they are asking the tensile side stress. They are asking the tensile stress. So tensile side y max is 70. Even if here y max is, this is 90, still we'll be calculating this. So this into 70 in proper units, in Newton, omega Newton is 10 to the power 6, you can find the answer. I'm not going into the calculation. I'm not going into the calculation, guys. Okay. So Dheeraj sir, welcome again to the session.
Yes, sir. So guys, now next question is from columns. Okay. So हमारा वादा है सारे topics पूरे करेंगे. So now solve the question from column, that is from Rankine load. So they have given you the Euler load as 1000 kilonewtons. Okay. And the crushing load is equals to 1500 kilonewton. You need to find out the Rankine load. So I feel everyone would be knowing that 1 upon PR is 1 upon PE plus 1 upon PCR. If you know this relation, you can very easily find out the Rankine load. This is from column and strut. Okay, so you can have this type of question. Wonderful. I feel some of you have given the answers. Easy way. Teju, Mayur, Manas, Abhishek, बहुत ही बढ़िया. Swapnil, Vishal, SK, SV, okay, Ashish Sharma, बहुत बढ़िया. Lucky Chandra, बहुत बढ़िया. So guys, the answer for this is going to be D, that is correct. So you would be having 1 upon PR is equals to 1 upon 1000 plus 1 upon 1500. So I feel you know the formula for PR would be 1000 into 1500 divided by 1000 plus 1500. The answer would be 600 kilonewton. So wonderful, guys. The answer would be D for this question. Moving to question number 18 now. Question number 18 now is from torsion. So covering all the topics, guys. Ha, Manas. I is BD cube by 12 and Z is BD square by 6. So we are talking about XX axis when depth is along the Y. Two shafts having same length. So L1 is equals to L2. Same material, G1 is equals to G2, are joined in series. Okay, are joined in series and they are subjected to a torque of 10 kilonewton meter. If the ratio of diameter is 2:1, then the ratio of their angles of twist would be. You need to find out the ratio of θ1 to θ2. If the ratio of diameter is 2:1, I feel everybody know theta is given as TL upon GJ. This type of questions are more coming in GATE for 1 mark, 2 mark section from the torsion. Okay, Teju have given the answer to be D. Yes. Very good, Mayur. Yes. So Ramesh Mon is saying D. Mayur, very good. Swapnil, Ashish, SK, बहुत ही बढ़िया. Ashish, very nice guys. So when you would be solving this, you know theta 1 by theta 2. This ratio you need to find out. So theta 1 ratio would be T1 L1 upon G1 J1 and T2 L2 upon G2 J2. So guys, they are subjected to same torque, length is same, material is same, everything will get cancelled out. This would be J2 by J1. Okay, J2 by J1. So J2 is going to be pi by 32 D2 to the power 4 divided by pi by 32 D1 to the power 4. So D2 to the power 4, D1 to the power 4, you can see the ratio of D1 and D2 is 2:1. So it is coming out to be D2 by D1 to the power 4. So it is 1 by 2 power 4. So I feel D is going to be the right answer for this. I feel all of you have given the right answer. Wonderful guys. बहुत ही बढ़िया. Very good Vishal. So answer would be D. Very good Lucky. So guys, like I feel we have done these two questions. Okay, one easy question. I am also not counting like Abhinav sir. हिसाब बराबर कर रहे हैं. So just give me the answer for this because elastic constant पर कोई question नहीं आया इसीलिए बस ऐसा हम कर रहे हैं. So for linear elastic isotropic material, the number of independent elastic constant. मुझे पता है बहुत आसान question है. Everyone would be giving the answer, but 1 mark में आ जाता है, तो इसीलिए हम risk नहीं लेंगे, ठीक है? So tell me the answer for this. Wonderful, wonderful. Question देखते ही answer निकला है बस. बहुत बढ़िया. Great, great, great. बहुत ही बढ़िया. So guys, you know that for independent elastic constant they are talking about. For homogeneous and isotropic material, out of 4 it is 2. For orthotropic, out of 12 it is 9. For anisotropic, out of 36 this is 21. So Abhinav sir, please come for the last two questions. Yes.
Okay sir, okay. So guys, let us do the last two questions. Okay. So this is question number 19. Now this is a rigid bar and I'm just, that was a horizontal case. This is a different case. The deflection at point B, since it is rigid, so it cannot be like this, as I just told earlier. Okay. Since it is a rigid, so the question, it will be deflecting like a straight one. It will not be bending like this. Okay. So here, whatever is the deflection, let it be delta from similar triangle. If this is delta, this is 2 delta from similar triangle because it is L distance away, that is 2 L distance away. So if this is delta, this is 2 delta. So we want deflection at B point. Okay. Now, since guys, this is a hinge. So if here it is spring is pushing it upward by F force. Spring is pushing it by upward F force. So summation of bending moment about A is 0. At hinge, bending moment is 0. Movement is everywhere 0. Guys, movement is everywhere 0. Bending moment is different thing, movement is different thing. Okay, just give me 2 minutes. I'll make you understand. Many times in interview, I ask somebody that this is P, this is L, this is B, this is A. What is movement at A? What is movement at A? Please let me know in the comment section. Please let me know in the comment section. What is movement at A? What is movement at A? Okay. So many students will be say, let me check. Well, let me check what students are saying. What is movement at A? P into L. Mayur is P into L. Ajay is saying P into L. All are wrong. Movement at A is 0. Bending moment is PL. Bending moment you see from right hand side PL. And these are the reaction. From left hand side also it is PL. So bending moment at A is PL. From right and left also. Movement at A is 0. Guys, movement at every equilibrium body has to be 0. Otherwise it will be rotating like this. Otherwise it is rotating like this. Movement is calculated from right also and left also. right PL clockwise, left PL anti-clockwise. Guys, even movement at every point in equilibrium body is zero. If movement at this point, C, that is distance is x, and that distance is L minus x. So movement at C. See this P into x clockwise. P into x is clockwise. This PL is anti-clockwise, and then this P into L minus x clockwise. Movement is taken from left and right both. So this is again zero. This is again zero. Movement at every point is zero. If you still not understood, let me tell you one more thing. Guys, it is same like now you will understand. Now you all will understand. If this is P force, this reaction is P. So at this section, net force is zero. Net force is calculated from bottom also, top also. At this net force is zero, otherwise it will be accelerating, it will be going to Khandala. Okay. Yes, the axial force is P. Axial force is either from bottom or top. Axial force is P here, but net force is zero. Okay, so bending movement here is zero. Movement to हमेशा zero होता है. So bending movement from right hand side 500 और movement तो होगा ही zero. Even movement will also be zero here. So 500 into this distance 2L. Okay, and this F is F into L is equal to 0. So F is equal to 1000. If F is 1000, what is delta? Delta is P by K, F by K. So 1000 by 50. 1000 by 50 is 20. So this is 20. Deflection is F by K. So this is 22, delta will be 40. D option. It will be D option. This simple E, G, K mu relation I told you in the morning. Na? E, G, K mu from this. It can, every question you can ask us in Telegram. Yeah? Any question you can ask us in Telegram. Last question. Question number 20. The modular ratio of material used in fleeced beam is 10. That means Young's modulus of this steel. This blue one is steel. Yeah, this blue one is steel. This blue one is steel. Okay? Steel is stronger. And Young's modulus of steel upon Young's modulus of wood, they are saying 10. Okay. Now, 4 different sections are there. The material shown has, this has one is larger. That means steel. Then the question is not written. Na? Let me tell you the question, which is strongest? Which is strongest section in bending? 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 And let me add one more thing. And which is strongest in shear? Which is strongest in shear? In bending, it is quite obvious. This is worst because bending stress are like this. Top and bottom more, and at the center it is very less. This is worst. Where the stresses are minimum, they are putting higher standard material there, good quality material there, stronger material there, worst design by a worst engineer. Okay. The best design is this one. Even this is also not best. On one side they have provided good, another side they have not provided. It is not mentioned as ductile or brittle material. So best is this. Even this is also not best. He has provided good material all throughout the section, all throughout the depth. But all throughout the depth, the stresses are not more. So this is best in bending. This is best in bending. Okay, and particularly shear stress, I told you, na? At top and bottom it is 0, and somewhere in the between it is maximum. So shear stress, we can predict that this may be good for shear because shear is maximum at the center or near about center, not exactly center. Okay, and here for bending, this is the best. For bending, which is strongest in bending. Even if, let me tell you one more thing. Even if it is not mentioned that which is the strongest, it is not mentioned. Okay, which is the strongest, and is not mentioned, and the word is mentioned beam. So beam, the primary stresses are always bending. We will be, if it is not mentioned bending or shear, we will be giving answer for bending. Or please remember this for the exam. Please remember this for the exam. Okay. But ductile wheeler is shear, so 3 not shear right. Yes. But ductile wheeler in shear, so 3 shear right. Okay, I'm not getting what you said. Okay, have you got it, guys? Please give me yes or no. Dheeraj sir, you can join us now. Okay.
Yes, sir.
Okay, guys, please give me yes or no. Have you understood? Give me yes or no. And guys, this is a scholarship test that will be on 8th January. Even you don't want to take course, please do this test so that you can check your performance on the All India level. Okay, now the schedule. Sonu sir will be coming tomorrow 10 a.m. Sonu sir will be coming tomorrow 10 a.m. for the complete thermodynamics. Okay, and Sahu sir will be coming tomorrow 10 a.m. for complete steel structure. 10 a.m. tomorrow. Okay, 10 a.m. tomorrow. Okay, sir, you want to add something?
So guys, I feel today was the first day of marathon series. So the starting was very nice and well begun is half done. So you just need to continue this series now to complete your all the subjects. And thanks for your love and support. If you would be continuing this, it will definitely give you a good revision plus confidence. And third thing is good coverage as you are doing revision with the faculties. And you are already getting these PDFs also. If you want to once again re-revise and give the test, this will also help you out.
Okay. Okay, guys, thank you. For any more updates, please let me know on the comment section. Let us know on the comment section, okay? And
yes,
this PDF,
if you want to ask anything, guys, you can ask even on the Telegram channels also. And join our Telegram channel so that you get the regular updates. Yes.
okay, guys, thank you, guys. All the best for preparation. We regularly will be coming after every day or 2 day or 3 day, okay? Like soil marathon is there for me. Toe marathon is for Dheeraj sir. Okay, so we'll all will be there. Okay. Thank you. Provide PDF. Yes, we'll provide. Okay. Thank you, Saksham. Thank you. Okay. Thank you. हो गया सर